Welcome to the discussion and thank you for always joining us. This is K.c.s.e 2006 paper 1 question number 24, a question on differentiation and its applications. And the question we have reads, a particle moves along a straight line such that its displacement s meters from a given point is t cubed minus 5t squared plus 3t plus 4, where t is time in seconds. Find part A, the displacement of the particle at t is equals to 5 seconds. In this case, the displacement function, which is part A, is given by s is equals to t cubed minus 5t squared plus 3t plus 4. And we have been told to find the same displacement of the particle at t is equals to 5. Therefore, we know at t is equals to 5 seconds, then the displacement is going to be equal to t. The value of t is 5, which is going to be cubed, minus 5 times t. The value of t is 5 squared, plus 3, you multiply by t, which is 5, and finally plus 4. And in this case, we are going to have an answer that is going to be equivalent to 19 meters as the displacement or distance. We move to part B of the question, and in part B we are told to find the velocity of the particle when t is equals to 5. Given the displacement function, then to get velocity you differentiate displacement in respect to change in time. That is, ds over dt will give us velocity, and in this case we are going to differentiate the displacement function. We start with t power 3, which is going to give us 3t squared. Remember, you bring down the power, then you less 1 from the power. Then for 5t squared, 2 multiplies with 5, so we are going to have minus, that is 2 times 5, which is 10. Then you go and less 1 from the power, we remain with t. Then for 3t, you differentiate 3t, you get 3. Remember, we are supposed to find the velocity at t is equals to 5. Since we have the velocity function, then at t is equals to 5 seconds, then the velocity is going to be equal to 3 times t, which is 5, but this one is squared, minus 10 times t, which is 5, plus 3. Remember, 5 squared is 25 times 3, which gives us 75, minus 10 times 5 is 50, plus 3, and this one is going to give us 75 plus 3, 78. 78 minus 50, you get 28 meters per second as the velocity of the particle at exactly t is equals to 5 seconds. We move to part C, and in part C we are told to find the values of t when the particle is momentarily at rest, and we know that at rest the velocity of the body is always 0, and therefore we take the velocity function, which is 3t squared minus 10t plus 3, we equate it to 0. Then from there we can be able to get the values of t. Remember, this is a quadratic equation. We are going to solve it using product sum factor method, where the product will be the first coefficient times the last one. That is 3 times 3 will give us 9, and the sum is usually equal to the middle term, which is minus 10. So in this case, the two factors will be minus 9 and minus 1, such that negative 9 times negative 1 will give us positive 9, and negative 9 plus negative 1 will give us minus 10. Once we have done that, we come and write this expression or equation, that is 3t squared. Then the middle term is replaced by the numbers, that is minus 9t, minus 1 is the same as minus t, plus 3, and this one is going to be equal to 0. Then we factorize this in pairs. Between 3t squared and minus 9t, 3t is common into 3t minus 1. The same bracket is going to be obtained here. So here we are going to have so this is wrong here. So between 3t squared and minus 9t, 3t is common. So inside we are going to have t minus 3. Then this one is also going to be t minus 3. That is the second part. We place negative 1 outside. And therefore this one is going to be 3t minus 1 and t minus 3. And this one is going to be equated to 0. Meaning 3t minus 1 will be equal to 0. 3t will be equal to 1, and therefore t is going to be a third seconds. And also t minus 3 will give us 0. T is going to be equal to 3 seconds. That is if you move minus 3 to the other side. That gives us the answer to Roman C of the same question. We move to D, and in part D we are told to find the acceleration of the particle when t is equal to 2 seconds. And we know acceleration is usually given by differentiating velocity in respect to time. And this one is going to give us the velocity function is 3t squared minus 10t. And if you differentiate this function, we are going to have 6t minus 10. And in this case, at t is equals to 2 seconds, then the acceleration is going to be equal to 6 times t, which is 2, minus 10. 6 times 2 will give us 12 minus 10. And this one is going to give us 2 meters per second squared as the acceleration of the particle when t is equals to 2 seconds. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, you click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. For online lessons, feel free to contact us through 0701 686 283. Thank you and welcome.